morning, good afternoon, or good evening, ladies and gentlemen. I hope you're doing well today. Welcome to Unit 10, which is called Electricity and Magnetism. New unit means a new set of objectives, so please pause the video for a few moments to read over the list of objectives as laid out by North Carolina's Department of Public Instruction. All right, let's go ahead and jump into our first lesson of this new unit. Lesson 10.1, Electric Charge. So what is electric charge? Well, electric charge is a physical property of matter. Remember, a physical property is a property that can be observed or measured without changing what a substance is made of. Charge comes in two varieties. We have positive charges and negative charges. Now, just as a matter of convention, positive charges will almost always be represented in red, and negative charges will be represented in blue. I also like to put the plus and the minus sign just to kind of help you out. In normal matter, that is the type of matter we've been studying for the whole semester, matter made out of atoms, positive charge is carried by protons, easy for me to say, and negative charge is carried by electrons. Now remember from way back in unit, I want to say 3, that protons are located in the nucleus of an atom, and they pretty much stay where they are. An atom doesn't tend to gain or lose protons. Electrons orbit around the nucleus in electron energy levels, and electrons can come and go. An atom can gain or lose electrons. Now, before we go any further, it's important to know that like charges will repel each other, which means a positive and a positive will push each other apart, or a negative and a negative will push each other apart. But opposite charges will attract each other. So here I have a positive and a negative charge. They're held apart from each other by clamps, but let's see what happens when we let go of them. They attract towards each other. All right, here we have two positive charges. When we let go of them, they repel or push away from each other. And the same is true for two negative charges. So opposite charges will attract together, but like charges will push away from each other. So as we said, atoms can be charged if they gain or lose electrons. Well, bigger objects can also gain or lose electrons, and therefore they can become charged as well. There's 3 basic ways that an object can gain or lose electrons: charging by friction, charging by conduction, and charging by induction. So let's talk about each one. Let's start with charging by friction. When something gets charged by friction, well, if you know what friction means, it usually means things are rubbing together. And that's exactly what happens here. We start off with 2 objects that are neutral, which means they have equal numbers of protons and electrons. We bring them together and they rub against each other. As they're rubbing together, electrons can scrape off of one object and stick to the other. And then when they separate, whichever object got the extra electrons, well, that one's going to be negatively charged, and whichever object lost electrons is going to be positively charged. Charging by friction is what happens when you walk across the carpet in your socks. You build up an electric charge, and then if you touch a metal doorknob or maybe another person, you feel a little jolt of electrical energy. And that's because all of that charge that's building up in your body suddenly leaves your body very quickly and gives off a lot of energy as it does. If you've ever jumped on a trampoline while wearing socks, you know you can build up a nasty electric charge, especially when you try to get off the trampoline and touch that metal frame. Oh boy, that's quite a shock. So let's take a look at a little animation that illustrates charging by friction. We have 2 objects here. The red and blue circles just represent positive and negative charges spread out evenly around the object's surface. We're going to bring them together, rub one against the other, and then when we separate them, some of the electrons from the first object have stuck on the second object. So this object becomes negatively charged, and this object which lost the electrons now has more protons than electrons, and so it's positively charged. This little boy has slid down this slide, and as he did, he charged himself up by rubbing against the bottom of the slide. And so you can see whenever your hair stands up because of an electric charge, it's because the electric charges try to get as far apart from each other as they can. And so they move out to the ends of their hair strands, and then the hair strands repel each other and stand up. This boy has been charged by friction. Next, let's talk about charging by conduction. Now, in charging by conduction, one of the objects already has to be charged. So maybe it got charged by friction against some other object. It doesn't really matter. The point is it already has a charge. The other object can be neutral. What happens here is the objects touch each other, and then some of the charge is transferred from the object that already has a charge to the object that doesn't have a charge yet. Now, when this happens, both objects are going to have a like charge. So, for example, if the first object is negative, then the second object is going to become negative also. And if the first object is positive, then the second object is going to become positive also. So here we have object A. Object A is negative because it has all these negative charges built up on its surface. We're going to bring it over and let it touch object B, which is currently neutral, and we're going to watch as some of those negative charges drain onto object B. So now both A and B are negatively charged. This happened because the negative charges on A are trying to get as far apart from each other as they can. So when they touched B, they were like, bingo, there's all this new territory that doesn't have any charge. And so it spreads out onto that new territory, and now both objects are negatively charged. The last method of charging is called charging by induction. And this is the most complicated one, so listen carefully. Like with conduction, one object has to already be charged, and the other object is going to be neutral. So that's the same as it was with conduction. But instead of touching the two objects together, we're going to bring them close together, but not actually touching. And then we're going to ground the neutral object, which means we're going to take a wire and we're going to connect it from the neutral object to the actual ground. And the ground is like a big storage vault for electric charge. So you can put huge amounts of electric charge into the ground, or you can take huge amounts of electric charge out of the ground. When we ground the neutral object, then the electric charge will drain into the ground, and it will leave behind an opposite charge from the original object. So I know that's pretty complicated to just talk about it and understand what it means. So let's look at an animation. Once again, object A has a negative charge. It has all these electrons built up on its surface. Object B is neutral, and this time I'm showing you the positive and the negative charges that are spread out on the surface. We're going to bring them close together. Now, this is all going to happen pretty quick. So what's going to happen is when A comes close to B, all of the negative charges are going to be scared away. They're going to be repelled by A. So they're going to drive over to the right-hand side. Then we're going to bring up a wire and touch it to B, and that will allow all of those electrons to run even further away from A. They're going to run down into the ground. Then we're going to disconnect the wire, and that will leave B with an excess of positive charges. So here we go. So after charging by induction, A and B have opposite charges. This is different from conduction, where they had the same charge after being charged. So that pretty much wraps up our 10.1 lesson. Take a minute to look at this diagram. This compares the similarities between the three different methods of charging. I'm not going to read it all to you. You can read, but I do encourage you to pause the video and take a minute to study it carefully. Make sure you understand these relationships. And come on back tomorrow. In lesson 10.2, we're going to be talking about electric circuits. And then in lesson 10.3, we'll talk about magnetism. Can't wait. I'm really excited for these topics. If you have any questions, please let me know. As always, there will be a short assignment over on Google Classroom. I encourage you to please check that out. As always, take care of yourselves. Keep washing those hands. We will see you tomorrow. Until then, have a great day. Bye.